Okay, the third handout of Unit 7, Section 1 is a more lengthy one because there's problems on both pages all the way through. So we're going to take a look at the odd ones. I'll let you do the even ones. Okay, so the first one. Number 1, the scatter plot shows the average traffic volume of average vehicle speed on a certain freeway for 50 days. So traffic volume and average vehicle speed. Okay, which statement describes the relationship? So it looks like the relationship's going down. So the more vehicles, okay, the average vehicle speed is high with less volume. More volume, less speed. So as volume increases, speed vehicle increases? Nope. Volume increases, speed vehicle decreases. I think that's the one, right? Volume increases down here, and the speed of the vehicle decreases. So B. Okay, I'll let you number 2. There's no correlation here, so that should be pretty easy. The graph shows no trend. Just by looking at this stuff is everywhere. Alright, that's a bonus one. Alright, number 3. Which graph best shows a positive correlation? The best one. So it looks like this is pretty good. There you go. Hey, that was an easy one. Alright, number 4, the scatter plot below answer the following question. So it looks like there's a positive correlation going on here. The number of tickets issued, the number of ticket writers. So as the tickets go up, we have more ticket writers. So they're both going up. Think about that as you consider what you're doing. And if it looks like maybe draw a line of correlation as best you can. That may help you decide which one to pick for number 4. I'll let you do that one. So that takes care of the first page. Alright, on to number 5, second page. Mr. Thomas wanted to know if the amount of class time, okay, your study time, would have any correlation with the test scores. And it looks like they're going up. So the more time, so you see that trend, the more time you study, the better test score. It looks like we're looking at a positive correlation there. Alright, number 6, same thing, things are going up. So as the heating time goes up, so does the water temperature. So think about that as you make your selection in number 6. Flipping it over, number 7, we have the following scatter plot. Oh boy, you got 2 low ones, the rest are going high. If you had to make a guess, maybe something like that. So as the length of feet increases, the weight in tons increases, so they both go up. So the weight of the dinosaur tends to increase according to its length. Yeah, we're thinking it's A there. Alright, number 8. Help me answer the question. So it looks like you got to plot these. So the number of students, that goes on the x-axis. Number of free throws goes on the y-axis. So if you plot those real quick, see what happens. Over 7 and up 3. Over 1 and up 2. Over 6 and up 6. Over 4 and up 7. Over 5 and up 2. Over 3 and up 4. And over 1 and up 3. So there you have it. I'll let you decide. It looks like a pretty obvious one there on number 8. Alright, so that takes care of those. Alright, third page, starting with number 9. Here's dots all over the place. Definitely no correlation here. No relationship between class size and number of absences. No correlation there for number 9. Number 10. Which data will most likely show a negative correlation, which means as one goes up, the other goes down. So you got to think about that. The outside temperature and the number of people wearing gloves. So as the outside temperature goes down, more people would be wearing gloves. So there you have it. As one goes up, one goes down. Okay. Alright, number 11. This definitely is a trend going down. So the speed on an airplane versus distance traveled in 1 hour. No, nothing there. So one go again. Since it's negative, something has to go up as it goes down. Outside air temperature versus air conditioning costs. So as the temperature goes down, the cost goes up. That would be 1. Outside air temperature, this is going to go down. No. Air temperature has to go up. Air conditioning costs go up. So it wouldn't be B. Age of an adult and the height of an adult. Now there's no correlation there. Distance traveled versus gas remaining in the tank. So the more I travel, the less I have. Again, more and less. Oh, there it is. D right there. Okay. Oh, this is an interesting one. Which is an example of a linear pattern? So they have to go up by the same amount every time. 1/9, 2/9. No, that's going up by times 2. Let's see, 2.36, that's 4, then 3. Nope, that won't do it. -5 to -1. Distance of 4. -1 to 3 is 4. 3 to 7 is 4. So this shows the linear pattern goes up by 4 every time. Up by 4 every time. Okay. Alright, flipping it over, which graph shows a line of best fit for the scatter plot? Okay, so this is a pretty easy one to take care of. Again, look, if you look at the dots, these are going down, so that doesn't work. This one's off too much because the line is way above it. This looks really good. The dots are coming down. This is right in the middle. So we're looking at C for a final answer there. Alright, going on, number 14. This one, let's see, the equation y equals half x plus 2. So you have to be able to graph that equation. So let's kind of refresh our memory. 2 is the y-intercept, and 1 over 2 is the slope. Okay, rise over run, 1 over 2. So if I go simply, let's just take a look at the very first one. Put a dot at the y-intercept, which is 2. Rise up 1, run over 2. There's my graph, and there's my line. So that one might be the closest one I would have to rise up 1, run over 2. Okay. Definitely not here, definitely not here, definitely not here. So A would be my choice. Again, y-intercept 2, slope, rise over run, 1 over 2. Okay. Alright, number 15. A researcher gathered to predict, way down here. After making the scatter plot of the dash, you determine the equation of the line of best fit is this. Based on the equation, what is the number of new types of plants that will be in the park after 24 years? Okay, now if I remember right, it says X is the years. So now, over here, y equals 0.25 times 24, because this is the number of years I want to use. Then I'm going to add 8. Okay, so just take your calculator out. 0.25 times 24, and I'm going to add 8. I get 14. So y equals 14, and there's my answer right there, 14. Alright. On the back side, oh, this looks pretty simple. Okay, here we go again. 16 says, which one, again, describe that relationship. 2 is the y-intercept, and my slope is 1 over 2. Okay. So I got to plot the y-intercept. No, it looks like I just did this one. Did I do 16 again? Looks like we just repeated it. So plot 2, go up 1 over 2, and draw my line. There we go. Let's say seems like I did this one already. Must be a repeat question. Yep, 14 was just like 16. Just different graphs. Okay, going on to number 17. Alright, getting near the time here. Let me see, which is the closest to the number of minutes it would take to complete 9 laps. So here's 9 laps way over here. Notice my line doesn't go up far enough. So extend your line. Now 9 laps. Take it up. and take it across about 5. Okay. Alright, next one. Which number best represents the slope of the line of best fit? So we don't have right now a line of best fit. So what you got to do is you need to draw a line of best fit as best as we can. So maybe something like this. There we go. Okay. So now to figure out the slope of the line, I want to pick maybe some points that are actually near some intersections for me. This one looks like a good spot right there. Another one, maybe I want to select a point right here. Even though it's not on my line, I'm going to use that. So the slope, rise over run. So if I'm here at 30, I go up to about 45, that's about 15. If I'm at 200, I'm going over to about 400. That's a difference of 200. So the rise is 15, the run is about 200. So let me do some reducing here. 5 goes into 15 3 times. 5 goes into 20 about 40 times. So I get 30 over 40. So I'm looking for a fraction, not very big. So 3 over 40 is about 0.075. So which number is closest to 0.075? And that would be 1/10. That's about 0.1. And it has to be positive because my line goes up and to the right. So again, this is an estimate, so you're estimating. So kind of keep that in mind. It's not going to be perfect every time. Okay. Alright, number 19. Which equation could describe the line of best fit for the above graph? Alright, so first thing I look for is y equal mx plus b form. And notice all these equations are written in that form down here. So the y-intercept, they all saying the y-intercept is 236. Okay, now my line looks like it's going up and to the right. So let's see, that means it can't be this one and it can't be that one, so I'm doing these two right here. Okay, so now I have to figure out, is it 5x or is it 1/5 x? 5x would go up pretty fast. Okay, that means I rise up 5 for every 1 I go over. This one I rise up 1 for every over, so they're just opposite. So here if I went up 1, I'd run over 5. Really hard to tell which one in particular. So I'm going to look at some points here. Okay. Over 1 and up 236. Gosh, it's really hard to tell. 0 and 236, comparing that to another one. What you'd have to do is see, 1 is at 2. Gosh, 242. 1 at 242. So let's do y2 minus y1 over x2 minus x1. So if I subtract the y's, that's 6 over 1. So it is a right there. Okay, we're going to stop the video and I'll let you guys finish out 20 and